Every rock on Earth tells a story, but it's like you have completely broken the laws of geology to create landscapes that look entirely alien. We're talking about stone icebergs that extend miles into the Earth's crust, a perfect geometric staircase built by cooling lava, and rocks that literally grew like giant pearls out of ancient mud. These aren't optical illusions, they're real locations. Today we're exploring 10 of the most famous rock formations on Earth, the bizarre science of how they have formed and were forged, and the hidden secrets millions of tourists miss. We start in the New Mexico desert with Shiprock. Rising nearly 1,600 feet into the sky, it looks like a lone mountain, but geologically speaking, you're actually looking inside the throat of a long-dead volcano. 30 million years ago, a massive column of magma froze solid right inside this volcano's main pipe. Over eons, the outer soft layer of ash and dirt completely eroded away, leaving behind an indestructible basaltic skeleton. And if you look at the desert floor nearby, you'll see massive stone walls radiating away from the peak like bicycle spokes. These are dikes, cracks where the lava violently shot sideways under immense pressure before freezing solid into solid underground walls. Shiprock shows us the hardened core of a dead volcano. But if you travel to Turkey, you can see what happens when volcanic ash gets trapped under heavy lava, and this created the Cappadocia fairy chimneys. These towering spines are made of two completely different rocks. The valley floor is tuff, a soft porous volcanic rock made from volcanic ash. The top layer is a heavy sheet of basalt lava. Over thousands of years, rain easily hollowed out the soft ash floor, but whenever a chunk of heavy basalt was sitting on top, it acted like a literal umbrella, shielding the ash beneath it, while the surrounding ground washed away, leaving towering stones cones wearing heavy boulder hats. In Turkey, water hollowed out soft ash, but in Arizona, water turned ancient sand dunes into liquid sandpaper to carve Antelope Canyon. This world-class slot canyon is cut directly into Navajo sandstone, ancient Jurassic sand dunes that turned into solid rock. But it wasn't carved by a slow river. During monsoon season, rain miles away funneled these narrow slots into a raging torrent of water. The water picked up loose sand and sediments, and it swirled into high-powered vortexes like that sandblasted the canyon walls, etching those famous fluid-flowing waves straight into the stone. Antelope Canyon shows how water and sand can strip away rocks, but on a beach in New Zealand, ocean mud did the exact opposite. It actually grew rock like giant pearls in the form of the Meraki boulders. At first glance, these look like giant dinosaur eggs that tumbled through the ocean waves to create these very large boulders that are very spherical, but they actually grew like pearls. 60 million years ago, in ancient sea floor, calcium carbonate began sticking into clumps around an organic core, like a fossilized shell. Millions of years, minerals crystallized outward to form concentric spheres inside the soft mudstone. Today, as a coastal cliffs erode, these preformed stone spheres drop perfectly into the sand. While coastal mud was shaping massive spheres in New Zealand, subterranean groundwater in Virginia was dissolving entire mountains to create a natural bridge. This 215-foot structure is the final ceiling of a massive collapsed mega cave, made entirely of limestone. It formed when acidic groundwater seeped into underground cracks, slowly dissolving a giant river cavern through the mountain. Eventually, the cavern grew so wide that the roof collapsed into the river below, except for this single massive structural arch. It is so stable that today a full U.S. highway drives right over the top of it. Acidic water hollowed out limestone bridges in Virginia, but in Colorado, massive mountain building forces slammed into ancient sandstone to create Red Rocks Amphitheater. The towering walls of Red Rocks are made of iron-rich sandstone that was originally deposited completely flat 300 million years ago. But 70 million years ago, the Rocky Mountains lifted them up like a giant fist, tilting these layers into a near vertical 60-degree angle. It has world-class acoustics because the sandstone is heavily cemented with iron oxide, reflecting the sound waves seamlessly back towards the seats instead of absorbing them. Red rocks was tilted up by tectonic pressure, but in Chilean Patagonia, magma forced its way straight through the Earth's crust to form the Torres del Paine. These three towering peaks form a geological sandwich. The main bodies of the tower is a bright white granite, but the very tops are a dark slate. 12 million years ago, a bubble of magma forced its way up through an existing layer of dark crust. During the Ice Age, glaciers eroded away the soft outer layers until it reached the granite, where it stopped dead in its tracks. This scraped away the surrounding materials but left dark capped mountains that look strikingly like caps. Just like the towers in Patagonia, Yosemite's Half Dome is a massive bubble of granite that formed deep underground, but its unique shape comes from pressure releases, unlike being formed by glaciers. Trapped deep beneath the earth, it took millions of years for this giant bubble of magma to cool during the time of the dinosaurs. As the eons progressed, the pressure released as the upper layers got eroded away. These pressure releases caused the upper stones to crack and peel off like a stone onion. And despite the popular myth, a glacier did not cut it in half. It was formed by natural vertical cracks caused the front to simply lose the battle with gravity and collapse into the valley. Half Dome cracked because of the low pressure, but in Northern Ireland, cooling lava shrank so precisely it looks like a man-made giant's causeway. Made of 40,000 interlocking basalt columns, this geological wonder proves that nature loves geometry. 60 million years ago, a massive lake of liquid lava began to cool and shrink. As it contracted, it fractured into 120-degree angles, the exact mathematical geometry required to relieve thermal stress with the least amount of cracking. The same physics as dried mud in a puddle, just scaled up to volcanic proportions. Last but not least, we have Uluru in Australia. Rising out of the flat Australian desert, Uluru is a geological iceberg. What you see on the top is just a single Absorki sandstone monolith that plunges 3.1 miles deep into the Earth's crust. Because the sandstone is rich in iron, it literally has eroded over the past eons and has created the dark red hue that it looks like right now. At sunrise and sunset, the rock acts like a natural projection screen, filtering the low-angle light waves and visibly shifting from dull gray to a glowing neon red. Next time you walk past an ordinary rock, remember, with enough time, pressure, and with the right chemical forces, the Earth can turn ordinary dirt into wonders that define our planet. Which of these rocks would you want to visit first? Let me know down in the comments. If you enjoy learning about rocks, like and subscribe. Join me tomorrow for the next episode of the Daily Pebble.